Chapter 15 of The Hurricane Hunters by Ivan Ray Tannehill. This LibriVox recording is in the public domain. Chapter 15, Fighting Hail and Hurricanes. I wield the flail of the lashing hail, and whiten the green plains under, and then again I dissolve it in rain, and laugh as I pass in thunder. Hebert. At first thought, most people would say that fighting hail has nothing to do with hunting hurricanes, but in one instance it did. It is an interesting story which shows how men will take risks in trying to control the weather. The story ends with one man giving up his life in a sensational adventure with a mysterious conclusion. Destructive storms are not very frequent in any one place, but most people are under the impression that they are. They are apt to remember bad weather and forget about the good. Losses of life and property and failure of plans and business enterprises are caused by storms or the wrong kind of weather, and such things are impressed on their memories. When rain is needed, it may fail altogether, or come in such quantities that fields and roads are washed out and there are floods in the rivers. A thunderstorm brings rain, but sometimes hail comes with it, destroying crops and damaging property. People have tried to overcome these bad effects of the weather in many ways. Irrigation has long been practiced in regions with scanty rainfall. Air conditioning affords relief from excessive heat. In many other ways, some foolish and some dangerous, men have tried to influence the weather. An interesting case of this kind, which appealed to the imagination of people in many countries, started near the beginning of the present century. It was an international battle against hail. Its origin was in the vineyards of Italy. Hail had done great damage there year after year, and finally an Italian got the idea that he might destroy hailstorms by shooting into them when they were just beginning. In those years cannon were used in battle. Loaded with big charges of gunpowder, these cannon hurled solid, heavy balls at enemy cities, forts, fleets, and troops. In time of peace, there were many of these old cannon around, serving no useful purpose, and the Italian had no trouble in getting one to try on hailstorms. But he was not permitted to use a cannon ball. It might have crashed into a neighbor's house or killed somebody in the vineyards. So he loaded it with gunpowder and fired it at the storm cloud, hoping it would create a disturbance in the atmosphere and weaken the hailstorm. It is an amazing fact that the vineyard of this Italian was damaged far less by hail than those of any of his neighbors, and the next year others tried firing a cannon with similar success. They became expert at it and learned how to load a cannon so that it cast a big, whirling smoke ring into the thunderstorm cloud. The news spread to other countries, and in 2 or 3 years there was a lot of hail shooting in different parts of the world. So they held an international hail shooting congress where they exchanged ideas and narrated their experiences. By the time the Second World Congress on Hail was held, a great deal of uncertainty had developed. It seemed that the first hail shooters had begun work at a time when it just happened that there was much less than the usual amount of hail. Also, there were explosions and people were hurt. One man was killed and another had an arm blown off. After a few years, all the hail shooting ceased. Even today, there is a good deal of mystery about the formation of hail, and many people think there are ways of preventing it or causing the storm to make little hailstones instead of big ones, and thus having much less destruction. Hail causes many millions of dollars worth of damage every year in the United States, and almost any effort to reduce the losses seems to be justified. Scientists believe that hailstones are very small in the beginning, but grow in size as they go up and down several times in the thunderstorm clouds. Even in hot weather, it is very cold at the top layers of one of these great clouds. Raindrops freeze and in falling gather more water or snow in these high regions. Soon they are caught in rising air currents and carried up into freezing temperatures again. On each trip up and down, another layer of water or snow gathers on the outside and is frozen. At last, the multi-layered stone becomes so heavy that they fall to the ground. In spite of rising currents, and as they leave the cloud, they come down with great rapidity and may beat crops into the ground, batter automobiles, break glass, and bruise and sometimes kill livestock. A hailstone the size of a baseball falling many thousands of feet is a very dangerous thing. For many years after the hail-shooting experiments, it was thought that nothing could be done about it except to carry hail insurance. Then, shortly after World War II, scientists of the General Electric Company announced that they had conducted some successful experiments in controlling the weather, and this led to efforts to control rainfall, prevent hail, and stop hurricanes. The man who started this new effort at weather control was Vincent Schaefer. He observed the weather on top of Mount Washington in New Hampshire, a place where it is very cold and windy in winter. The observatory is fastened to the solid rock of the mountain top by steel cables to keep it from being blown off. Vast quantities of ice accumulate on the building. Snow comes down in great quantities at times, but is generally carried by high winds which have reached terrific speed, on one occasion going up to 231 miles an hour. Conditions there are, in some respects, like the weather in the top of a big thunderstorm. One of the peculiar things that happens up there on Mount Washington and in the top of a thunderstorm is the formation of liquid water droplets, which are colder than freezing, but they do not turn to ice. These droplets are said to be supercooled. Schaefer found in his experiments at General Electric that a small pellet of dry ice, the size of a pea, when dropped into air containing a cloud of supercooled water droplets, could produce untold billions of small ice nuclei. So he carried some dry ice up in an airplane and dropped it into the top of a cloud with supercooled water droplets, and a trail of snow was seen falling from the bottom of the cloud. Many others tried the same experiment, and some had similar results. The snow turned to rain as it came down to warmer levels, and the process was called rain-making. There is one disturbing fact. Before dry ice will work on a cloud, it must be very near the point of making rain without any outside help. But many of the rainmakers believe that dry ice makes more rain fall or causes it to fall sooner than it would otherwise. Thus, as the cloud moves along, the rainmaker may be able to cause a shower in a certain place, whereas the cloud might have moved far away before it began to rain. In this story, the important point is that some of the experimenters believe that dry ice or some other chemical will cause the rain to fall, but will make it much less likely that nature's process will develop to the point of producing hail. The news of all this rain-making in the West aroused intense interest on the part of a young man named Gordon Clouser. He thought he might be able to prevent hail, and if he succeeded, he might stop tornadoes. In the Midwest, there is an old story about a farmer who knocked the life out of a tornado by hitting it with a 2x4. On hearing this story, many people have gotten the idea that the government might destroy a tornado by gunfire. More recently, there have been serious proposals that these vicious local storms with funnel clouds and violent winds be destroyed by guided missiles. There is no evidence that any of the plans offered so far would be successful in breaking up hailstorms or tornadoes, but they are extremely small when compared with hurricanes, and the government has received thousands of proposals that these great storms be wiped out or rendered harmless by gunfire. Behind most of these suggestions for killing hurricanes is the idea that they begin as small whirls in the atmosphere and go through early stages of growth to the size of a tornado or a thunderstorm, and if they could be hit with great force in a vital place while small, they might die out. On this assumption, there have been a great many proposals that the Navy send battleships into the hurricane area to search for incipient hurricanes and fire broadsides into them. No test of this kind has been made for two reasons. The hurricane region is so large that the entire Navy would be insufficient for such a patrol. On the other hand, there is not a shred of evidence that hurricanes begin as small storms like tornadoes or thunderstorms. Actually, they seem to develop as mildly disturbed weather over an area of thousands of square miles. The experts say that shooting at the weather in such a large region would certainly be futile. After the World War II, the atom bomb stimulated some new ideas, and thousands of letters were written to the government about knocking a hurricane out with an atom bomb at the right time and place. When the New Mexico atom bomb was exploded, the weather was bad, with rain in torrents, strong winds, lightning, and thunder. Afterward, the weather was much better, and this led to a lot of speculation. The fact is, however, that the scientists waited until the weather improved before they exploded the bomb. Hence, neither the bad weather nor the improvement could be attributed to the explosion. Before the tests at Bikini in 1946 and in Enowetok in 1948, the scientists received numerous letters warning them that the explosions would start storms and might cause a typhoon. But the effects of explosions of this kind are soon over, while the forces that maintain a hurricane or typhoon must be applied continuously day and night for a week or two to keep one of these big tropical storms going in full fury. One of the scientists who witnessed these tests estimated that it would take 1,000 atomic bombs at any moment to equal the energy of motion in a hurricane. No scientist has figured what would happen if 1,000 atomic bombs were exploded at one time in a storm area. After a year or two of rainmaking with dry ice and another chemical, silver iodide, the conviction grew that it would be possible to kill a hurricane by dropping some of this material in a vital spot. Some of the bolder students of weather control actually tried it. One of them was Gordon Clouser. Just what he did when he flew into the storm and what happened to it afterward make a mystery, for he gave his life in the effort. It is a good example of the fearless activities of the hurricane hunters. Gordon Clouser was born in 1912 in Gibraltar, Pennsylvania. He grew into his teens as an active, good-looking boy with many diverse interests. Quick to learn, he finished high school at 14. His family moved to New Mexico, where he worked several years as a surveyor, then took 2 degrees at the University of New Mexico. After that, he had many activities: teacher, librarian, writer, and director of plays. He made a movie, composed music, wrote poetry, was in the Air Corps Reserve one year, taught meteorology and aeronautics at Boeing Aircraft in Seattle for a year and a half. He learned to fly in Idaho, and then was a teacher in junior college in Yakima, Washington. It was 1950 when Gordon became excited about the work that was being done in rainmaking in many parts of the country. By April of the next year, he had moved to Plainview, Texas, and had begun to organize airplane operations to prevent hail on the high plains of the state. Having developed his own secret formula for the chemicals to be dropped into thunderstorm clouds, he experimented in his car, in airplanes, and in the home freezer. Once he came home for dinner carrying some denim to be used in connection with an experiment, and his wife discovered that he had taken all the food out of the freezer so he could drop chemicals in it to see what might happen in the atmosphere. When asked what they were having for dinner, she replied, "I guess it will be frozen denim." The year 1951 was not an easy one for Clouser. The thought of preventing hail was new to most people, and he had some difficulty in getting enough money to finance the necessary plane operations. He asked farmers for 20 to 40 cents an acre for protection from hail, and compared this cost with the much higher rates for hail insurance. But, he argued, the prevention of hail would lower the insurance rates, which are based on the frequency of such storms in any area and the amount of damage done. To prevent hail, Gordon and his pilots flew into and over thunderstorms to see if they contained hail in dangerous sizes, and if so, they dropped his secret chemicals into the tops of the clouds. This is called seeding by rainmakers. Gordon was sure that he was preventing hail damage from the clouds they seeded. By 1952, he had 9 planes at his command. In that year, from June 1 to October 1, they checked 421 thunderstorms and found ice in dangerous sizes in 82 of them, which were seeded. He reported to the farmers that there was no appreciable hail damage from any of them, and there were no complaints on that score. During this time, he was watching the reports of tornadoes and getting the Weather Bureau's forecasts and warnings. On May 26, he heard a prediction of tornadoes in an area which included the 2 counties where he was working to prevent hail. Without regard for the danger of flying among thunderheads in tornado weather, his planes were in the air for a total of nearly 10 hours that day, seeding clouds that looked dangerous. That night, a half hour after the last of Gordon's planes landed, the Weather Bureau issued an all clear. There had been no tornadoes in either county. Gordon said, "We can't prove that we prevented a tornado. Maybe none would have formed anyway, but we do know that conditions were right for one, and we changed those conditions." For a man of Clauser's adventurous spirit, this was just a side issue. He occupied much of his spare time studying hurricanes and making plans for the day when he would be operating a large company to kill these storms before they reached the coasts of the United States. He hoped to have his main office in San Juan, Puerto Rico, with planes stationed also at Pensacola, Florida, on the coast of Mexico, in Cuba, and at 2 or 3 other strategic places. He would get the government reports, talk to the weathermen, and at the right time drop a mixture containing his secret formula into the eye of the storm or some other vital spot that he would find by flying above the storm clouds and studying the wind circulation. His wife, Olive, took this philosophically. With their 3 children, she was living at Norman, near Oklahoma City. Like the wives of most adventurous pilots, she knew that any one of these trips might be her husband's last. She encouraged him in his hail prevention, but worried about tornadoes, and especially hurricanes. She knew that they form and move over vast sea surfaces on which the winds impress violent motions, a deadly place for a man to land when in trouble. After Gordon flew into the tornado clouds in May, he came to Oklahoma City by bus and called her on the phone to come and get him in the car. Instead of going home, he asked her to drive him to the Weather Bureau office at the airport, where he checked on the reports to see if they knew what had happened to the tornadoes. Then she found out what he had been doing and heard him talking about hurricanes. Olive had something special on her mind. She wanted to paint the kitchen yellow, but he was against it. She tried to get a compromise. If he was going to fly into tornadoes and other storms against her advice, why not paint the kitchen yellow, even if he didn't like it very much? He offered strong objections, and she put it off for a while. In the meantime, Gordon was in trouble. September of that year, 1952, was very dry in Texas. The farmers in Floyd and Hale counties in that state got the idea that his agitations against hail had prevented rain. Anyway, he was out of work, for, as he said, there is no point in a hail-busting business when there are no clouds. A delegation of farmers called on him to protest his activities. They said that he and his men had deprived them of rain, and they were going to lose a lot of money. Gordon convinced them that his work on the clouds earlier in the year had nothing to do with the drought. He pointed out that only 82 out of 421 storms had been seeded. Therefore, 339 of them had acted exactly as nature had intended. Besides that, he showed them news reports that nearly all of Texas was dry, some parts being much drier than the counties he was working. They went home satisfied, but Gordon had time on his hands, with no thunderheads or clouds to work on. So he gathered data on hurricanes and spent a good deal of time at home, making experiments in the freezer. He wanted to work on big storms. The little ones in Floyd and Hale counties gave him trouble. All rainmakers know that it is possible to seed a cloud and have rain on the farm or ranch of a man who refuses to pay for seeding, and have no rain on a farm next to it owned by a man who had paid for the service. October came, and it proved to be the driest month for the country as a whole since weather records began. All the rainmakers were in trouble, and the hail-busters were out of work. Gordon sat at home, listening to the radio and working on his formula. He and Olive talked about many things, but neither mentioned hurricanes or yellow kitchens. Then, on Tuesday, October 21, Gordon left for Plainview. The next day he heard a news report from Lubbock that there was a hurricane in Cuba moving toward the United States. On Wednesday he left for Florida in a Luscombe plane, saying nothing to anybody except Bill and Pauline Sarp. Bill was not a pilot, but Gordon had been teaching him to fly. Knowing nothing about the trip to Miami, Olive was having the kitchen painted yellow and wondering what Gordon would say when he came home from Plainview. That was on Thursday. On Sunday, the 26th, she and the children had a late breakfast, but managed to get to Sunday school and remained for church service. During the hymn at the beginning of the service, there was a long-distance call for Olive from Plainview. Gordon was lost at sea. Later in the day, she heard the story in full. Gordon was not satisfied with the plane. When he reached Florida, he tried to get one better suited for storm work. He had plans for building a special plane for the purpose, but now he was anxious to get into the hurricane. It might be the last one of the season, he thought. It had done a great deal of damage in Cuba. He went to the Weather Bureau office in Miami and got the latest information on the position, strength, and movement of the storm. At 3:45 p.m., October 25, the center of the hurricane was about 75 or 80 miles east of Miami when Gordon took off in his Luscombe plane. At 8:56 p.m., a radio station in Miami picked up a message from him saying that he was 50 or 60 miles east-southeast of Miami, still in the edge of the storm. The radio station talked with him for 26 minutes as he flew toward Miami, making poor headway against the winds. The last message was, "Out of fuel, descending, give my love to my wife and family." The Civil Air Patrol and the ships and planes of the Coast Guard searched the area for 48 hours without finding any trace of the missing man. Olive went to Miami and did her best to keep the planes looking for him. Whether or not he had any effect on the storm will never be known for sure. The weather forecasters in Miami did not think so. But the hurricane soon afterward took an erratic course. It was destructive early on the 26th as it turned into the Bahamas, then lost force and turned northward. The official report of the Weather Bureau said that it moved northeastward thereafter as a disturbance of no great violence. The uncertainties and the tragedy in this case brought to mind the Savannah storm of 1947, which Gordon may have studied. It began far to the southward near the Isthmus of Panama early on the 9th of October. On the 11th it crossed the extreme western end of Cuba, and on the 12th passed over southern Florida. From this time on, its course was very unusual. Reconnaissance planes followed it going northeastward over the Atlantic until the night of the 13th, when it was east of Wilmington, North Carolina. Early on the 14th, a plane got into the storm area and found it moving southwestward. With considerable force, it struck Savannah, Georgia, early on the 15th, causing about $2 million worth of damage. Citizens of Savannah and some of the city officials complained to the government for causing the hurricane to strike the city. At about the time, or just before the hurricane changed its course abruptly to the southwest, military planes had carried out an experiment in dropping dry ice into its upper levels. There was a great deal of discussion in the press. At first it was said that the dry ice had caused the storm to take a new course, but after the Savannah complaints were heard, little more was said by the military about the experiment, and it remains something of a mystery. Few scientists believe that dry ice would have such an effect on so large a storm. Actually, there were few observations in the storm area during the night of the 13th to 14th, and precise information about the time and nature of the change of course was not available for an investigation. It belongs in the same class as the Clouser storm. End of chapter 15.